going to utilize this acrylic aldehyde to react with the aniline. Okay, so here I have taken acrolein. Okay, alpha beta unsaturated carbonyl alpha beta unsaturated aldehyde, and we have to react with the aniline. Okay, so now lone pair which is present on the nitrogen atom, this is 1,4 addition again. So it adds via 1,4 addition to the carbon carbon double bond alpha beta unsaturated carbonyl carbon, and generation of positive charge. Again, negative charge generated on oxygen atom. On H plus you have in your uh, flask reaction flask, so that one is abstract proton, or we can say this O minus abstract proton from this nitrogen atom which is positively charged, and now it make the neutral component. On tautomerism there is a enol form and keto form, we can exchange this one. So now two hydrogens they have generated on these two carbon atom. Again on treatment with H plus, this we made this oxygen atom, or carbonyl carbon is more electrophilic for the nucleophilic attack now. Okay, by protonation of this oxygen aldehyde carbonyl group. And once this carbonyl carbon is getting highly electropositive, becomes highly electropositive, nucleophile from the benzene ring, okay, carbon carbon double bond from benzene ring attacks on the carbonyl carbon, and in this way we can reach up to this intermediate. Okay, so now again we have to retain the aromaticity by the elimination of proton. So we have regenerated the aromaticity of the benzene ring, side benzene ring. Now again we have only challenge now, that retain the aromaticity of the pyridinyl ring. Okay, so abstraction of proton, elimination of water molecule. Again the elimination of water molecule we have done over here. Then the elimination of proton, one or two proton. After elimination of one or two proton, we are come to we can reach over here, and we can what is the role of nitrobenzene. So here is the role of nitrobenzene getting started. Nitrobenzene acts as a solvent as well as oxidizing agent. So in presence of nitrobenzene, these two hydrogens they can getting removed from this one. So this molecule is getting oxidized to form our desired quinoline. So this is the famous scrap synthesis for the quinoline, and this is very important in our syllabus. Now we'll switch to the next. And this is short. In short, I have given here the scrap synthesis. Nitrobenzene serves as both solvent and oxidizing agent. The reaction, which otherwise has a reputation for being violent, is typically conducted in the presence of ferrous sulfate. Arsenic acid may be used instead of nitrobenzene, and the former is better since the reaction is less violent. Okay, arsenic acids we do avoid, because arsenic is not very good for it's not environmentally friendly. That's why we do use nitrobenzene. So here is the, in short, I have given the same mechanism, scrap synthesis, treatment of the aniline with this acrolein, and how the eventually we come after oxidation. Iodine also we can use as oxidizing agent, and finally we can get this our quinoline. So acrolein can be generated in situ by treatment of glycerol with concentrated sulfuric acid. So this mechanism we have seen already in our previous slide. So mild oxidation is required to form fully aromatic system for the dihydroquinoline. So here this one is the dihydroquinoline, and that one is upon oxidation gives the our desired quinoline molecule. This is modified synthesis, or modified some different catalysts. They have used zinc chloride and Fe3 as a Lewis acid catalyst. So with the help of this one also we can synthesize our substituted quinolines. So this is the scrap synthesis, which is 3 plus 3 cycloaddition reaction. So not cycloaddition, but 3 plus 3. We can add three molecules from one starting material, three molecules from the three atoms from the another starting material. So next synthesis of the quinoline is comb synthesis. So here we have to use aniline. As we know, we need this benzene ring and nitrogen atom. So aniline is a very good starting material, and now we have to, after finishing, we need four carbon atoms still. Sorry, three carbon atoms, 1 2 3, and these three carbon atoms we can take it from the this 1,3 diketone. So we are going to react this aniline with this 1,3-diketone compound to generate the remaining 3 carbon atoms. So in this way, on next step on treatment of the H2SO4, we can achieve this quinoline synthesis. Okay, comb synthesis invented in 1888. So reaction mechanism undergoes the 3 major steps. First one is being protonation of the oxygen on the carbonyl in the beta diketone. Okay, so it's obvious that we have to make this carbon atom more electropositive by protonation of this carbonyl group, which this undergoes nucleophilic addition of this aniline. Aniline attacks this carbonyl carbon. An intramolecular proton transfer is followed by the E2A mechanism, which causes the molecule of water to leave. So we'll see now on next stage what is the reaction mechanism. So here I have given protonation of 1,3-diketone we have done over here to make this carbonyl carbon more electropositive. Now nucleophilic addition of this lone pair of this aniline occurs across this carbonyl group. So here I have shown how the nucleophilic addition occurs across this carbonyl group. Okay, so there is a generation of OH. NH2 plus still possesses this uh, positive charge. Now this lone pair which is present on the OH group that abstracts proton from this nitrogen to form OH2, and as we know proton after proton transfer we can eliminate this OH2 in form of water molecule. So here by pushing this OH2 we have generated C double bond N bond and we have eliminated water molecule. Again on treatment with H plus, carry on treatment with H plus. Okay, elimination of H plus. After elimination of this H plus from this nitrogen atom, we can reach the imine formation. Okay, so imine formation is a double bond. N bond is nothing but the imine bond, and this imine on rearrangement or tautomerism, we can say this forms the enamine. Okay, so enamine is nothing but the carbon-carbon double bond next to the nitrogen atom. Then this enamine undergoes rearrangement when treatment with the H plus. Again, as H plus we do use, if ketone group is there, then abstraction of this proton by ketone group, carbonyl group, it makes carbonyl carbon positively charged. Then lone pair from the benzene ring attacks on the carbonyl carbon, and we can here generate the ring now. So first we generated ring here of this quinoline compound, and now we have to induce the aromaticity. So eventually you can see there are some steps we have taken. We have induced aromaticity of benzenoid ring over here, and now we have to eliminate this hydroxyl group in form of water molecule. So that one we have eliminated water molecule, and then after some time we have to do the proton elimination or shifting of proton or abstraction of proton or elimination of proton. We can reach to the quinoline, and this is the home synthesis of the quinoline. So this is also very important reaction type, home synthesis of quinoline. So first one is scrap synthesis we have seen, second one is comb synthesis. This is also 3 plus 3. So three atoms we have taken from here. Okay, from 1,3-diketone, and 3 atoms we have taken from the this aniline moiety, one nitrogen and 2 carbon atom. So 3 atoms from here and 3 atoms from another starting material. So 3 plus 3. This is a combination for the foam synthesis. Okay, so next step is so here how to compare the comb synthesis as well as Friedlander synthesis. Okay, so comb synthesis I have given, Friedlander synthesis, see the how I have written the starting material. So in both things, comb synthesis we have taken the aniline and we have taken 1,3-diketone. So see how I have written these things, so we can generate this quinoline moiety very well. Okay, so this one we have to just attach over here. So NH2 benzene ring, nitrogen atom comes over here, carbonyl group, and we have to generate this elimination of H2 and O water molecule. We can generate C double bond N bond, and uh, and again we can join this carbon atom and we can generate this carbon carbon double bond. We'll see, we'll go for now the next Friedlander synthesis in short.